What is AWS Lambda and why is it helpful for us? So let's take an example. We are going to start with Amazon EC2. And Amazon EC2, as we know, they're virtual servers in the cloud, and we have to provision them, so we are limited by the amount of memory and CPU we're going to provision. They have to be continuously running. I mean, we can optimize them by starting them and stopping them efficiently, but otherwise they run continuously regardless of if something's happening or not on your instance. And if you want to scale, you can use auto-scaling groups, but that means that you need to do something to automatically add and remove servers. Now, this is one way of doing things, and it has worked great, but then there is AWS Lambda. So with Lambda, these are virtual functions, no servers to manage, so that means that we just provision the code and the functions run. It is limited by time, so we're talking about short executions of up to 15 minutes, which is, in my opinion, not that short. And then finally, they run on demand. So that means that when you don't use Lambda, your Lambda function is not running. And you only are going to be billed when your function is running, and it will run on demand when it gets invoked, which is a huge shift from Amazon EC2. Finally, the scaling is automated. If you need more Lambda functions, occurrences, and the concurrency, then automatically AWS will provision for you more Lambda functions. Magical. We'll see this in the hands-on. So benefits of Lambda, I'm sure you see many. First of all, the pricing is super easy. You're going to pay for the number of requests Lambda receives, so the number of invocations, and your compute time, so how long Lambda was running for. There is a very generous free tier on Lambda, which is 1 million Lambda requests and 400,000 gigabyte seconds of compute time. It is also integrated with so many AWS services, as we'll see. We can use a lot of different programming languages on Lambda, so we're quite free. And there's very easy monitoring integrations with CloudWatch. Finally, if you wanted to provision more resources per function, you can provision up to 10 gigabytes of RAM per function, which is a lot. And by the way, you need to know this, if you increase the RAM of your function, then it will also improve the quality and performance of your CPU and network. So now let's talk about the language support for Lambda. We have Node.js for JavaScript, Python, Java, which is Java 8 compatible or Java 11, C# for .NET Core, Golang, C# for PowerShell, Ruby, and you can write pretty much any language for Lambda thanks to the custom runtime API, which is community supported. And for example, if you want to run Rust language functions on Lambda, it is possible thanks to an open source project. So Lambda has a lot of language support, and it also has support for the Lambda container image. So this Lambda container image is quite special. The container image itself must implement the Lambda runtime API. So it's not any container image that can run on Lambda. There needs to be some prerequisites about how that container image is built. And then ECS and Fargate is going still to be preferred for running arbitrary Docker images. So at the exam, if they ask you to run a container on Lambda, unless that container does implement the Lambda runtime API, you will want to run that container on ECS or Fargate. Now, I said that Lambda was integrated with so many AWS services, so I'll give you a few and some idea of how they're integrated. And in this course, we will see some of these integrations. So API Gateway is to create a REST API, and they will invoke our Lambda functions. Kinesis will be using Lambda to do some data transformations on the fly. DynamoDB will be used to create some triggers, so whenever something happens in our database, a Lambda function will be triggered. Amazon S3, we've seen it already. A Lambda function would be triggered anytime, for example, a file is created in S3. CloudFront, this will be Lambda at Edge, and I have a lecture dedicated to this in this section. CloudWatch Events or Event Bridge, this is whenever things happen in our infrastructure on AWS and we want to be able to react to things. For example, say we have a code pipeline, state changes, and we want to do some automations based on it, we can use a Lambda function. CloudWatch Logs to stream these logs wherever you want. SNS to react to notifications in your SNS topics. SQS to process messages from your SQS queues. And finally, Cognito to react to whenever, for example, a user logs in to your database. So these are just the main ones. There are tons of Lambda integrations. And so I want to show you a very good example here, which is a serverless thumbnail creation. So let's say we have an S3 bucket and we want to create thumbnails on the fly. So there will be an event, which is that the new image will be uploaded in Amazon S3. This will trigger through an S3 event notification a Lambda function. In that Lambda function, will have code to generate a thumbnail. That thumbnail may be pushed and uploaded into another S3 bucket or the same S3 bucket, which would be a smaller version of that image. And also, our Lambda function may want to insert some data into DynamoDB around some metadata for the image, for example, the image name, size, creation date, etc., etc. And so thanks to Lambda, we've automated and had a reactive architecture to the event of new images being created in S3. Another example that's extremely popular is a serverless cron job. So cron is a way on your EC2 instances, for example, to generate jobs every 5 minutes or every Monday at 10 a.m., etc., etc. But you need to run cron on a virtual server, so an EC2 instance and so on. And so while your instance is not running, or at least your crons are not doing anything, then your instance time is wasted. And so as such, you can create a CloudWatch event rule or an event bridge rule that will be triggered every 1 hour. And every 1 hour, it will be integrated with a Lambda function that will perform your task. So this is a way to create a serverless cron because in this example, CloudWatch events is serverless and Lambda functions are serverless too. Now let's take an example at the Lambda pricing. So you can find all the information on this website in case the information here is outdated, but it will give you an example of how that works. So you pay per calls. The first 1 million requests are free, and then you're going to pay 20 cents per extra 1 million requests. So that makes a very, very cheap request. Then you're going to pay per duration in increments of 100 milliseconds. So you get the first 400,000 gigabyte seconds of compute time per month if for free. And then what that means, this gigabyte seconds, is that it means you get 400,000 seconds of execution if the function has 1 gigabyte of RAM. That means you get 8 times as more seconds if the function has 8 times as less RAM, so 128 megabytes of RAM. And after that, you're going to pay $1 for 600,000 gigabyte seconds. So to be honest, you can make the math. It's usually very, very cheap to run your code on Lambda. So it's a very popular option to create your applications. So that's it. Now let's go into the hands-on to get a feeling of how Lambda works.